Welcome back. In this video, we are going to solve problem 10-87 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is if a solid shaft having diameter d is subjected to a torque T and moment M, show that by maximum shear stress theory, the maximum allowable shear stress is this one. Assume the principal stresses to be of opposite algebraic sign. So you can see this is a shaft that is subjected to torsion or torque on both sides, which are opposite, creating twisting effect, and there is a movement which is producing bending effect. So you have to prove this allowable shear stress using maximum shear stress theory. So let's start with the solution. Now you can see that due to movement, we will have bending stress, which is equal to sigma x, and this sigma x will be equal to m into c divided by I, where m is the moment, c is the radius, and I is the moment of inertia. And again, due to torsion, we will have shear stress, and that shear stress will be equal to tau of xy will be equal to T into C divided by J, where C is the radius, J is the polar moment of inertia. So what we are going to do is that we will find this C. So C will be equal to diameter is given, so C is equal to D divided by 2, and what we have is we have I, which is the moment of inertia, and for circular rod it is equal to pi by 64 d power 4. Similarly, J is the polar moment of inertia, and for circular shaft, solid shaft, it is equal to pi by 32 d power 4. Okay, now we have all these values. So what we can do is that you have to just plug it in this formula. Sigma x is equal to m, c is again d divided by 2 divided by I is pi by 64 d power 4. So you can see this 2 will cut with this, so it will be 32, and 1 d will cut with this, so we will have 32m over pi d cube. So I can write it, sigma x is 32m over pi d cube, where m is the moment, d is the diameter of this shaft. Now you can see that you have the second formula is this tau of xy is equal to T into C divided by J. So T is there, C is D divided by 2, and J is pi by 32 d power 4. And that will give you 16t over pi d cube, because 2 will get cut with this, so it will be 16, and 1d will cut with this. So from here you will get this tau of xy is 16t over pi d cube. So this is the shear stress due to torsion. Now you can see you have sigma x, which is 32m over pi d cube. Sigma y is not there, which is 0, and tau of xy is 16t over pi d cube. So we are going to find principal stresses, because we are going to apply the maximum shear stress theory. So for that we will need principal stresses, and this principal stresses sigma 1 comma 2 is sigma x plus sigma y divided by 2 plus minus under the root sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. Okay, so just plug the value. Sigma 1 comma 2 is sigma x is 32m over pi d cube plus 0 divided by 2 plus minus under the root 32m over pi d cube minus 0 divided by 2 whole square plus tau of xy is 16t over pi d cube whole square. Okay, and what we will get here is that sigma 1 comma 2 will be equal to 16m over pi d cube plus minus under the root, this will also 16m over pi d cube whole square plus 16t over pi d cube whole square. Okay, now if you take, this will be equal to 16m over pi d cube plus minus, if you take 16m over pi d cube, not 16m, 16, if you look at, we have 16 over pi d cube whole square common, so it will give us m square plus t square. Okay, so making this term out of the square, so it will be 16m over pi d cube plus minus, this will be 16 over pi d cube because the square will cut with the square root and we will left with m square plus t square. Okay, that will sigma 1 comma 2. So sigma 1 will be equal to 16m over pi d cube plus 16 over pi d cube into m square plus t square, and your sigma 2 will be equal to 16m over pi d cube minus 16 over pi d cube into m square plus t square. What we are going to do is that I do not have sufficient space, so I will copy that and we will move toward next page. Okay, so we have this equation and we have been given that both sigma 1 and sigma 2 have opposite signs. So it means that one is positive, sigma 1 is positive value and sigma 2 is will give you negative value. So if I plot them on this axis for Mohr circle, so x-axis will have normal stress and on y-axis we have shear stress. So let's say this is your sigma 1 and this is your sigma 2. Both have opposite signs. So what we are going to do is that I will have the Mohr circle will be like this one. If I draw it like this, so it will be Mohr circle. The Mohr circle will be like this, and we will have this allowable shear stress or maximum shear stress. So this is maximum shear stress, or we can also say that allowable shear stress. So this allowable shear stress will be equal to which one? So you can see this is radius, this is also radius. So how will you find? If you take this whole, which is sigma 1 minus sigma 2 will give you this distance. This is sigma 1 minus sigma 2, and if you divide it by 2, so we will get this distance. So sigma 1 minus sigma 2 divided by 2 will be this one. So I can write it sigma 1 minus sigma 2 divided by 2 is this shear stress, allowable shear stress. So if you put this allowable shear stress, sigma 1 is how much? 16m over pi d cube plus 16 over pi d cube into m square plus t square minus, and this value is 16m over pi d cube minus 16 over pi d cube into m square plus t square divided by 2. Okay, so this will be like this. Okay, now you can see when this minus will multiply with this, so it will be minus and it will be plus. So this minus will cut with this and we will have this value as plus. So I can write it that allowable shear stress will be equal to 2 times 16 over pi d cube into m square plus t square divided by 2, and this 2 will cancel with this, so we will have allowable shear stress is 16 over pi d cube into m square plus t square, and this is the answer, and we will check that whether we have proved it or not. So I have to compare, you have to remember this. So you can see we have been asked to show that this allowable shear stress is 16 over pi d cube into m square plus t square under the root. So you can compare these two values. And this was all about this problem 10-87. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.